Hello, MathSci here. I want to take a look at a problem on finding the molecular geometry of this compound. And to make life easier, we're going to go through a series of steps. And so that's how we're going to solve these problems. So our first step is to count the valence electrons in this compound. So for xenon, there are 8 valence electrons, and then you add the number of valence electrons in oxygen. So you just multiply because there's 2 oxygens, and there's a total of 6 valence electrons in oxygen. And then you add the fluorine, which there are 2 fluorines, so you multiply that by 7 total valence electrons in fluorine. And then that would be a total of 34 valence electrons. And if you want to find the pairs of the valence electrons, you would just simply divide by 2, and you would get 17 pairs of electrons. And because of these pairs, that will help you in drawing your Lewis dot structure, which is our next step. So to draw the Lewis dot structure, you would simply put xenon as your central atom. And then you would start drawing the oxygen and the fluorine as so. And then don't forget to complete your octet. And then also, since xenon is in group 7, group 8 in the periodic table, you would have to include 2 more electrons, which makes it a lone pair in xenon. So since we have the Lewis structure, we want to look at a model to help us determine the shape for our VSEPR, which is in step 3. So here's the model. So this is the model of the compound, and as you can see here, there's a lone pair. Here's a lone pair, and this would be the fluorine. These are the 2 fluorines, and this would be the oxygen. And see, and by looking at this would help us determine the VSEPR of the compound. So that would be our next step. So the VSEPR would simply look as such. So you have 2 lone pairs on xenon, and then you would simply write or draw the line and make sure it's linear, with a straight edge. Make it slightly to the right, and then you would put fluorine there, there. Make sure you put your electrons. There. And then you have to draw your wedges. So that would be for oxygen. And then here you would draw the other oxygen, but make sure. So now, don't forget also that when you're drawing your VSEPR, you have to count how many groups or electron groups the central atom has. So in this case, you have 1, 2, 3, 4, and 5. So that said, you would simply have 5 electron groups in this VSEPR model. And now, also another thing you have to remember is what are the angles in this VSEPR model. So for this one, you would simply write for this angle, it's less than 180 degrees, and on this angle right here, it's less than 90, and then right here, it's less than 120, and that's how you would write your angles for the VSEPR model. And that's very important because this helps in determining the repulsion of the model. See, because of the lone pairs, because of these lone pairs, this pushes the angles a little bit more closer together. In the next slide, we will see a model on how this VSEPR looks like. So here's the model of the VSEPR, and that's how it should look like. And in our next step, we determine what is the name of this VSEPR model. So now, just by seeing this seesaw, and we would just simply call it a seesaw. So that's how you would determine the name of the molecular geometry, by all those steps. And if there's any questions about this particular problem, please leave a comment, and I will very surely get back to you, and I'll try and do some more videos of these so it's understandable to do. Thank you. This is MathSci here.